Okay, for this video, I'll be going through thermal properties of metal, tutorial question 8. Now, a liquid is placed in a test tube and allowed to cool to negative 30 degrees. Okay, so possibly it is placed in a freezer or something. Okay, the figure below shows the cooling curve obtained. State why the internal store of the sample, right, is losing energy throughout the experiment. So, as I mentioned, it is probably placed in a freezer, and this liquid initially is at liquid state. So once it's placed in a freezer, temperature decreases until the freezing point. Okay, this part is the freezing point, and then all the liquid is changing state to solid state. Once all the liquid has been changed into the solid state, then the temperature will continue to decrease. Okay, so the answer is very simple. Temperature of the liquid is higher than the surrounding. Okay, due to the difference in temperature, net energy is transferred from the molecules in the liquid to the surrounding, and therefore it is losing energy throughout the experiment. So please read the question carefully. Part B, explain why the temperature of the sample is constant for some time. So it is only at this place whereby it's undergoing freezing. Okay, so why is the temperature constant for some time even though energy is lost to the surrounding or transferred to the surrounding? Now, when the temperature of the liquid reaches the freezing point, so this is the first key term, okay, put it in the answer. The energy, which is your latent heat of fusion, is transferred to the surrounding so that stronger intermolecular bonds are formed between the molecules. Okay, and the molecules decrease their intermolecular distances, and this is a change in state, freezing. Okay, there's a change of state from liquid to solid without a change in temperature. Now, this is important. During this process, total potential energy between molecules decreases, right? Because the distance between the particles becomes smaller, they are closer together. So their total potential energy between molecules decrease, but the total kinetic energy of the molecules remain constant. And since internal energy consists of internal potential energy and internal kinetic energy, although kinetic energy remains constant, but potential energy decreases, therefore overall internal energy decreases. Okay, next, since temperature is directly related to average kinetic energy of the molecules, temperature remains constant during the freezing process. It is only after all the liquid has been converted to the solid state, then the temperature will continue to decrease, because at, let's say this is 0 degrees, it is still higher than the freezer's temperature of negative 30 degrees.